All right, so here is Unit 6. First question, we're finding an area R that's bounded by two different functions. They're in terms of y. So since I'm finding the area between two curves and they're in terms of y, I know I'm going to be doing right minus left. And I know that my integral has to be based on the y values. So I'm going to go ahead and draw a sketch. Now, I feel pretty comfortable drawing a sketch of this while it's solved for y like that, because to me this just means it's a parabola that's on its side. It's either going to open to the right or open to the left. And this, so I'm kind of thinking of it like this, like drawing my paper sideways. And minus 3 at the end usually means move your parabola down 3. 1, 2, 3. So I'm just like, oh, there's my parabola right there. You can choose points. I know how parabolas grow. But you could always, if you needed something pretty accurate, you could draw it kind of like not very accurate. You could like truly just sketch it first and then see if you needed more accurate points to be able to get it. So there's our sideways parabola. This I went ahead and solved for the y. X equals 3y plus 1 minus the 1 over x minus 1 equals 3y, divide by 3, 1/3 x minus 1/3 equals y. I did that because I don't know what was messing with me. I guess I could have turned it sideways for that one too. So minus 1/3 up 1 over 3. It looks something like that. And then the area between them is right in here. Again, I'm going to do right minus left, and my y values are the important ones here, so that means that I have to set my equations equal to each other and solve for y to see what my interval should be. So I'm going to say y squared minus 3 equals 3y plus 1. It's a quadratic, so I need it to equal 0. So that's going to be y minus 4 and y plus 1. So y equals 4, y equals negative 1. So I know my intervals from negative 1 to 4. If I do right minus left, I know that it's the line minus the parabola. So it's the line minus the parabola. Oh, and it's minus, so that's a plus. So let's see. All right, rotating about the line, x equals negative 3, so I just went ahead and added to my picture here. And I remembered we've got two options. We have the disk method and the washer method, and with the disk method, our curve should be rotating around that axis of symmetry like that. It should be right upon it. With a washer, we're going to have some white space in there. So what I noticed is that there's some white space that's going to happen here. And so that told me that I should be doing the washer method. So with the washer method, I need to know what my big radius is and what my little radius is. So my big radius is the one that's further out, and again, we're doing right minus left. So the one that's further out minus the axis of symmetry in this case. So that would be 3y plus 1 minus negative 3. And little r is the curve that's closer minus the axis of symmetry. So that is y squared minus 3 minus negative 3. And so this is 3y plus 4. This is y squared. All right, so it's pi and then big R squared minus little r squared, and the interval is negative 1 to 4, and so that matches up with E. All right, Q is bounded by y equals sine of 2x, the x-axis, the y-axis, and then pi halves. So I know that a typical sine graph does this, and that's from 0 to 2 pi. And I know that a graph of sine of 2x is going to mean that the period is being divided by 2. So that means that instead of that being 2 pi, that's just going to be pi. So it means pi halves is right here. So that means we're finding this. Okay, so what is the area of Q? That's Q right there. So I'm going to integrate from 0 to pi halves of sine 2x dx. And this is a u substitution problem. So u is 2x du is 2 dx. I do not see a 2 there, so I have to divide it out and put it in the front. So I've got 1/2 sine of u du, and the antiderivative of sine is negative cos. So negative 1/2 cos u, so that's negative 1/2 cos 2x evaluated from 0 to pi halves. So I've got negative 1/2 cos of 2 times pi halves minus negative 1/2 cos of 0. So negative 1/2 cos of pi is negative 1. So that's negative 1/2 times negative 1 is positive half. And then minus minus makes a plus. And then 1/2 cos of 0 is 1. So 1/2 times 1 is 1/2. And 1/2 plus 1/2 equals 1. So the answer is 10. All right, number 4. Which of the following gives a solid whose base is the region Q? So that's the problem we just did. That's kind of nice if you weren't sure what the problem was supposed to look like. Then you could have, and I guess you didn't even really need to know what the problem looked like for you to be able to find it. That's funny. Either way, you can kind of see it here. You can see that, like, if you can kind of see through the shading. Anyway, the cross section's perpendicular to the x-axis. If they're perpendicular to the x-axis, that means we're doing everything in terms of x. They're squares. So S is going to equal sine of 2x. I'm ignoring the answer choices because I see coses in there and that's confusing to me. So I'm just going to look at this. So I know that area, I'm going to use my interval 0 to pi halves. The area of a square is s squared. So I've got sine of 2x being squared. I don't need a pi in the front. This is not revolving, so there's nothing to do with circles here, so I just have to do sine squared. So that is 0 to pi halves of sine squared 2x dx. And then I'm just going to look and see what answers could go. So, we have it. We have it exactly. It's right there. Now, the other ones, these were kind of distractor answers, but not. 1 minus cos squared is sine squared, right? That's the Pythagorean identity. So the reason that A is wrong is because of that pi. If they didn't have that pi there, then that answer would have totally been fine. So just be careful to watch out for that. They're checking to see if you could do the problem. They're also checking that you know the notation. All right, for this shape, I went ahead and I started writing my integral, and I said, okay, I know that it goes from 0 to 2. I can see that. Everything's in terms of x, which is why I did 0 to 2, so I can do top minus bottom. So I wrote down, I had the top, which was 3 plus square root of 4 minus x squared, minus the bottom, cos pi fourths x. And then this is where I kind of got stuck. So I guess you can kind of split this apart. 0 to 2 of 3 plus 0 to 2, 4 minus x squared minus 0 to 2 of cos pi fourths x. And when I looked at this, I was like, well, I can integrate this, but I can't integrate this. It feels like it should be u substitution, where the u is like 4 minus x squared, but then the du is not there. And then I checked my yellow sheet, and it wasn't. It was like real similar to some of the stuff on the yellow sheet, but it wasn't a yellow sheet problem. And then when I looked at this one, I was like, well, at least I know how to integrate that. So I kind of got stuck on this one. And then once I looked at the answer key, I was like, oh, I could see what they were thinking. So I'm going to tell you how I did the problem, and then I'm going to tell you how the answer key did it. So the first thing I did is I was like, well, I'm not going to be able to integrate this by hand, so I need to like think through. Sorry about that. So I need to think through the answer choices. So I just looked and I was like, this is like 1, 2, 3, 4, 5, 6, 7, like 8-ish is what my area seems to be. So then I knew that these two answers definitely couldn't be it, because 6 plus 2 pi is about 6. Those are each like 12, give or take a little bit, and that's way too big. So I was like, okay, that kind of helps. You know, I narrowed it down to 3 choices. I was pretty sure it wasn't A, because I knew that my area, when I counted the boxes, like seemed like it was going to be more than 6, but I wasn't positive. So I knew that when it came down to it, I was really going to be guessing between B and C. So then I thought, well, maybe the 6 plus pi comes from the first part, so I can just see what this part is and kind of narrow it down. So that's what I did. So I took this one because I knew how to integrate that one, and this really is u substitution. So I said u is pi fourths x, du is pi fourths dx, and we don't have a pi fourth sitting in the front, so we got to bring it out. So that means I've got negative 4 over pi, and then cos u, and the integral of cos is just sine. So that's sine of pi fourths x. And then this is being evaluated from 0 to 2. So I was like, all right, let me do this. I've got negative 4 over pi times sine of pi fourths times, that's a 4, pi fourths times 2, minus negative 4 over pi times sine of pi fourths times 0. Okay, so pi fourths times 2 would be 2 pi fourths, which is pi halves. And so sine at pi halves is 1. So that's negative 4 over pi times 1. Minus minus makes a plus. 4 over pi times sine at 0, because 0 times pi has to be 0. Sine at 0 is 0. So I was like, okay, that's negative 4 over pi. And from that, I decided to go with answer B. And answer B is correct. So perfect, that's it. Now, the way the answer key did this is they looked more at like the like actual definition of like why it works that you subtract one from the other. So what they did first is they looked at the area of everything beneath f of x, like everything. So if you look at the area underneath f of x, you can see that you have a quarter circle right here. You guys can see that? And you might recognize that because this is like what a circle looks like. The equation of a circle looks like when you isolate the y. So I'm like, oh, I guess I could see that. And then they saw this rectangle here, which was a unit, which had 6. So they said that the area was 6 plus, and then the quarter circle was 1/4 pi r squared, and the radius of that was 2. So 2 squared. So the area of this whole thing was 6 plus, that's 4, so 1/4 times 4 is 1. So 6 plus pi, and then you minus off this little piece, and you can actually do that by hand. And so then we're going to say, okay, if we minus off the 4 over pi. So that's how you actually get to answer B, but you could get there even if you weren't exactly sure how to do the problem. All right. problem 6 is still using that information from problem 5, so they still have similar curves going on there. And it says that we're going from 0 to 2, and this time we have that same coast graph, but it has a different vertical stretch happening, or a different amplitude happening. And it asks for which value of k does the region bounded by f of x and the line y equals 3, so this space right here, have the same area as this. So where can I make these two equal to each other? So you can actually use that same idea of a quarter circle. Like, I wasn't able to do this problem until I saw the answer for number 5, and then I was like, oh, that's what they want you to do. So the area of this one, it's a quarter circle, so 1/4 times pi r squared. And so that's 1/4 pi times 2 squared, which is 4, and so that's just pi. So that's the area right there is pi. And then the way to do this one by hand is we're going to integrate 0 to 2 of cos pi fourths x, and I've got a little coefficient of k in the front, and I want to know when that equals pi. Well, I already did, not the k, but I already did the work for this. So I already know that this stuff equals, what does it equal? -4 over pi. I know that that stuff already equals -4 over pi. So all I did is I said k times -4 over pi needs to equal pi, and then when I solve that, I know what my k is. So then I went ahead and multiplied by pi over -4. Actually, it wasn't. Sorry, our area should not be negative. Our area should be positive. It was negative because we were subtracting it off. This should be positive. So I'm multiplying by pi over 4 on each side. So k equals pi squared over 4. And if that is the vertical stretch, or if that's the amplitude, then these two will have the same area, even though they look like different shapes. So the answer for that one is C. All right. Number 7, air is being pumped into a spherical balloon at this rate, but there's a small hole in the balloon at the same time that's leaking out. Which of the following on the interval from 0 to 10 is, so which of the following is true? So when I looked at this, there's a couple answers you can get rid of pretty quickly. So when it said, like when I looked at B, I was like, that's definitely not true, that there's an increase of volume each minute during the first 10 minutes. I was like, the increase in volume is not going to be the same. Yeah, that's kind of how I took that problem was, well, I guess this would be the average value. But I got rid of this one real quick. And then I started looking at D and E. I wanted to get rid of those quickly too. So I looked here and I could see, and you can use a calculator. So if you look at R of 0 minus L of 0, I just went ahead and plugged 0 into each of those to see if it really did equal 1. And it did not equal 1, so I knew that that was an easy fix. What I did next is I went ahead and I found the derivative of R and the derivative of L, and that takes a little bit more work because the derivative of these is not super easy to find. I mean, this one's 1 plus sine of t plus 1. That one's not bad. But tan inverse is the 1 over 1 plus x squared, so you kind of had to remember that. So I went ahead and plugged that in. I could see those were definitely not 0, so I got rid of some easy answers there. So when you narrow it down, A and C feel really similar, and it comes down to you actually knowing what an integral truly represents in this context. So, because we know we're saying the air coming in minus the air that's escaping is the air that you're getting. Like, we kind of know that, but now we have to think, does the 0 to 10 mean the volume of the balloon after 10 minutes, or does it mean the increase in the volume during the first 10 minutes? Like, because they're similar, but they're different. So what helped me think through the problem is I was thinking about what if the integral was from 10 to 10? Because by the reasoning of answer A, If 0 to 10 is the volume of the balloon after the first 10 minutes, then for me, from 10 to 10 should be the volume of the balloon at 10 minutes exactly. So like not after 10 minutes, but at 10 minutes exactly. And I knew that this, anytime you evaluate an integral and it's the same number to itself, then the integral is just 0. There's no like area there. And so that told me that it's not the volume at 10, so this answer wouldn't make sense. The volume of the balloon from 0 to 10, that's like an accumulation. So it told me that it represents the increase in the volume during the 10 minutes, and that is the answer. And that kind of goes along with the idea of the integral as accumulation or net change. You're saying how the balloon is changing within the 10 minutes. You're not getting a conclusion of a total area. You're saying what is happening during that time specifically. So, and this kind of goes along with some other problems we did. So for instance, if you're saying the balloon had 50 cubic centimeters to start, then you would have said 50 plus this integral to get your actual answer. So we did problems like this before. I guess that number 7 just kind of was a little bit tricky, and I really had to think through it so I could get the right answer before I looked at the answer sheet. All right, for number 8, says that we have the revenue and expenditures for a small company, yada, yada, yada. Here's the revenue, here's the expenditures. They want to know the average annual profit. So profit tells me we're going to do revenue minus expenditure for the company when the expenditures reach a maximum value. Okay. So what I did first is I knew that I had to find that maximum value, so I graphed the expenditures, and I narrowed my graph down to just look at 0.5, and I found the maximum. That's what I did first. So I'd say you should go ahead and do that just to make sure you can find it. And I got the point 4.0772086 211716 58. Okay, so that was the point that I got, and that's like the max for the expenditures. Then you have to deal with the part where it says average annual profit. So I knew the annual profit was going to be R of t minus E of t, and I wasn't able to really think through the rest of it, and I did end up getting this problem wrong. So here's the stuff you have to think about when you do this problem. It says average annual profit, and what they mean by that is like the mean value of the profit. So if we think about the mean value theorem for integrals, because we're adding things up, we're going to say that's 1 over, and the profit would be, what is the profit when you reach this? So from 0 to this time. So 4.077 minus 0. Now, of course, when I use this, I didn't want to use a rounded number right here at the beginning, and so I did type that decimal in every time. I just don't feel like writing it. All right, and then in here we have R of t minus E of t dt. So I went ahead and once I knew that this is how you do it, I was like, oh, that's not too bad. Plug that in, and you do get 106,615.21. And if we had rounded, I guess they said round to the nearest dollar. If we'd rounded the way they did, we would have gotten this one. But the answers are far enough apart, you can easily tell which one is supposed to be yours. All right, so for this one, region G is bounded by the curve y equals ln x, and x equals e. X equals e is a vertical line. So ln x looks like this. X equals e looks like this. And then on the x-axis, so this is our shaded region G. And then I went ahead and I found these points of intersection right here. So this is, if you plug in E, you get 1. This is the point 1, 0. All right. So I'll say I totally did this problem wrong. Like I got this one legitimately wrong because I was thinking all of these were vertical lines. I did it as though all of those were vertical, and they're not. They're horizontal. So just be careful of that. So for the area, for the first one, or sorry, it's being rotated, so the volume, it's going to be pi. The interval is from 1 to e. And then if we're rotating it around the x-axis, that is the disk method. And so it's just going to be top minus bottom. So ln x minus 0 squared dx. And when you plug that into your calculator, you get 2.257. For the second one, if we have this line right here, we got pi. It's going to be the washer method this time, so we're going to do top minus bottom again, but it's going to be the curve minus the axis of symmetry. So that's going to be oh gosh, y equals 1, not negative 1. So, one's right here. Whew, okay, so yes, washer method, top minus bottom. So the top is the axis of symmetry. So 1 minus the one that is furthest from it would be minus 0. 1 minus, and then ln x squared. And when you type that one in, you get 4.027. And then the last one is using e, which would be quite a bit higher up here. So it's going to be e minus 0 squared, and then e minus ln x squared. And that gives you 14.823. So it looks like the first one is the smallest, and then the second one is the middle, and the third one is the biggest. So D is the answer. All right, number 10. For this one, we've got the base of the solid is on the plane. Each cross-section perpendicular to the x-axis. So since it's perpendicular to the x-axis, that tells me I'm using x values. Is a rectangle with one side on the xy plane and whose height is 2. So since one side is on the xy plane, that's this part right here. So I know that my s is going to equal my top minus bottom, whichever one happens to be on the top, whichever one happens to be on the bottom. So I know that rectangle is base times height, and the height is 2. So my rectangle is going to be base times height, which is s times 2. So what I did next is I went ahead and I graphed these two curves to see where they intersected, so I would know what my intervals were for my integral. And so they're symmetric, so it intersects at negative 1.041044, and then positive 1.041044. And then when I looked to figure out top minus bottom, that gave me that my s was going to be, the top is the tan squared x minus the bottom was 4 minus x squared. And it was just, this is our s, and it was s times 2, so I went ahead and put a little 2 in the front there. So when you type that in, you end up getting that the answer is E. And I would encourage you not to just copy it down, but to type it yourself. Make sure that you're capable of doing that. All right, number 11. For this one, to find the combined area, it means you're finding this one right here and this one right here. And so you definitely need to know what these x values are, because you need to know what your integral is going to be, what the bounds are. So this x value right here was negative 0.3103328. This one was 0.505082661. And then this one was just 1, so that was nice. So what I did then for this one, this first area, Again, I used the whole decimal because I didn't want to round until the very end, but I don't feel like writing the whole thing right now. So I did negative 0.310 to 0.505. And I did top minus bottom, and the top is e to the x minus 1, minus the bottom was x squared e to the 1 minus x to the third. And then I added to that the other one. And this one goes from 0.505 to 1, and then top minus bottom, x squared e to the 1 minus x to the third minus e to the x minus 1. And I just plugged that all into my calculator, and I got 0.276. Again, you should be typing these. Some of you guys let me be your calculator too long and then realized that there's so many parentheses involved in these that you can't get them right when you do them on your own. And that is not the place you want to be when you are approaching this AP exam. All right, it says, how far to the right of the starting point will the particle be at pi halves? So this is kind of like a net change or an accumulation problem. So I just said 0 to pi halves of this function. So e to the t sine of e to the t dt. Plugged into my calculator, got A. It's like, sweet, that was an easy one. Now here's where they make you question yourself. They said, what is the distance that the particle has traveled on the same time interval? You might be thinking, wait, isn't that just the same thing? The answer is no. So we don't just want to know how far it has come total. We want to know how far it's traveled. Like, has it gone back and forth? Is some of the space that it's traveled redundant? Did it go to the right 2 and then left 1 and to the right 5 and left 2 and then add it all up? So if you guys recall, the way that we do that is we take our function, we put it in an absolute value sign. And then we can see what all that back and forth traveling is, because it's going to add up all of those distances rather than have positives and negatives canceling each other out. And so this one, you actually get E when you plug it in that way. So that is very much like a conceptual question, just making sure that you understand the difference between those things. Question 14 is real similar to question 12. It just gives you a starting point. So instead of starting at 0, you're starting somewhere else. So we're starting at -1, and we're saying how far when it's the furthest to the right on this time interval. So to know what time interval we're talking about, we need to know when the particle is moving to the right. And we know the particle is moving to the right when the velocity is positive. So I'm going to go ahead and take that velocity function, that's what I did, and I graphed it. And I only looked at the graph from 0 to pi halves, and then I wanted to see where it was positive, because that kind of tells me where to look on this. So I could see that my interval for time was from 0 to 1.1447299, because that's where the velocity graph is positive. That's where the velocity graph is above the x-axis. So once I had that, then I went ahead and said, all right, -1 plus my integral, because that's the position, of the function, so of v of t. And then I went ahead and plugged that into my calculator, and I got 0.540. All right, for this question, I went ahead and I drew a little sketch, so we're allowed to use a calculator here. And so the first parabola gave me something like that. And then the second one was just like a little bit off kilter like that. So the first thing I did, I knew that I was finding this area right in here. So the first thing that I did is I found those intersection points. so that I knew what my x values were, and I figured out that it was 1/2 to 2. And we're making a volume, so I know I should have pi in the front. We're rotating about the line y equals -2, which is the horizontal line down here. Definitely a washer method problem. So then I figured out what my big R was. I've got to do top minus bottom. So 1 plus 3x minus x squared minus -2. So that's big R squared minus little r squared. So top minus bottom. And then just think about simplifying it. So minus minus makes a plus. So I've got 3 plus 3x minus x squared. And then I've got x squared minus 2x plus 5. And so that goes with C. All right, and then for our free response here, so it says, let f be the function e to the x plus 1 as shown in the graph below. The region is bounded by f of x, the y-axis, and y equals 4. So this is the region R that we're looking for. Part A says just to find the area of the region. So, and you can use a calculator. So if you want, you could graph y equals 4 and e to the x plus 1 to see what the decimal is for that intersection and just say 0 to that decimal. I went ahead and I just set the two things equal to each other. So I said e to the x plus 1 equals 4. And I subtracted the 1 over, e to the x equals 3. And I took the ln of each side. And so x equals ln 3. So I just used the exact number instead of the decimal. Ultimately, it doesn't really matter. I want to say when I looked at the answer key, I'm pretty sure they actually used the decimal. When they did it, yeah, they used the decimal. So we're going from 0 to ln 3. So for the area, we just do top minus bottom. So the top is 4, and the bottom is e to the x plus 1. And you don't really even need to simplify that. I mean, you could. So it's negative e to the x. That's a -1 and a positive 4, so that's 3. So if you want to do that, you can. And then I went ahead and just typed it in, and I got 1.296. It's an area. Yeah, the area of the region, units squared. This problem was worth 2 points. 1 for taking this integral, and then 1 for the answer. And the answer, that doesn't look like they gave points for the units. All right, part B. This one says we've got a vertical line, x equals h, where h is chosen so that the area of the region bounded by the same stuff is half of the area of this region. So we're doing a very similar integral. We're saying from h to ln 3 of 3 minus e to the x dx. And we know that it's going to end up equaling half of what this equaled. So I'm going to say equals this decimal divided by 2. So what I went ahead and did is we got to solve for h. Right, that's the problem, that's what we're trying to do. So at this point you have to integrate this by hand because you can't plug h in on your calculator like that. So the integral of 3 is 3x minus the integral of e to the x is just e to the x, and we're evaluating that from h to ln 3. So I said 3h minus, sorry, I'm going backwards. 3 times ln 3 minus e to the ln 3, subtract 3h minus e to the h, equals the 1.296 divided by 2. So we got to solve for h, and what you'll notice at this point is that this entire equation only has one variable. It only has h. So what you can do is you can take this and graph this is y1 and graph this is y2 and just see where the two graphs cross, and that will give you your h value. Now when I did that, I found two h values. I found that h was approximately 0.361 and that h was approximately 1.691. And for me to make sure that the answers made sense, I went ahead and I plugged them back in here to see if they equaled the decimal I wanted them to equal, and they were close enough with some rounding decimals to be feeling pretty good about it. And then I was like, well, which one should I use? And then I looked back at the picture and realized that they were pretty clear in the picture that your answer should be a small decimal, and it can't be greater than 1 because that would be like on the other side. That would be like your area going further over here. So so that meant, I was like, okay, so that means that this is the h value that we have, and that was the right answer for B. So if you look at B, it is worth 2 points, 1 point for the integral. And it looks like I set it up a little bit differently than they did. They were setting it up as like finding the area that they were taking away. But I think you'd get full points for this as well because it's still doing it with the same sort of mentality. So 1 point was for the getting that antiderivative, so getting this part, and then the other point was for the answer. All right, part C says find the volume of the solid formed when the region is rotated about the line y equals 4. So for part C, I said, all right, we're going to do pi r squared. It's rotated around the axis, and so that means this is a disk method problem. So I said 0 to ln 3 of, and I did top minus bottom for my r, so top minus bottom, r squared. And I typed that into my calculator, and I got 5.930. It'd be units cubed. In this problem, they're not really grading units. So this problem is worth 2 points, 1 point for the thing that you're integrating, 1 point for getting the answer right. All right, and then part D was asking, you have a horizontal line y equals k this time, where k is a value that's bigger than 4. So they're telling you that the line that you're rotating it around is going to give you a washer method problem instead of a disk method problem. And you want the answer to be twice the volume found in part C. They want you to set up but not to evaluate it. So I went ahead and I started it, and I said we got pi. When we do top minus bottom, so I'm going to picture this. I'm going to be flipping back and forth a little bit. So we have the line y equals k is like up here. So I'm going to do top minus bottom for the further one, which is the e to the x minus 1, and then top minus bottom for this one. So my further one was k minus e to the x plus 1 squared, minus my closer one was k minus 4 squared. 0 ln 3. And it has to equal double the area of the answer that we just got in part C. And so I did that 5.930. I used the unrounded version of it, and I multiplied it by 2, and I got 11.860. And that's all they wanted you to do there. So the points, it's worth 2 points. And it says they gave you a couple different options for how they'd score it. They said no points if you didn't do difference of squares, one squared minus another squared. They said 1 point, 1 point maybe. It says if you did f squared minus g squared. I'm not sure what they mean by that. And then 1 out of 2 points if you reversed these, if you had the wrong one. So that's how we scored that one.